Hello everybody, this is Yumeng from the University of Florida. This is the demonstration for my project of the course number EEL6562, the image processing and the computer vision. My topic is image segmentation based on the Iterative Threshold algorithm and the Ostu Threshold selection algorithm. Okay, here's the problems I want to start it in my project. The image segmentation, the thresholding basic theory, and the two classical methods to do the image segmentation, the iterative and the Ostu. Okay, let me briefly introduce what is the image segmentation. Well, image segmentation always occupies an important position in the image processing technique. Meanwhile, it is a classical top topic in the computer vision research. The quality of image segmentation can determine the results and affect the efficiency of the image processing. Well, in order to do the image segmentation, there are plenty of methods. Here I list some classical ones. The thresholding, the histogram-based methods, the region drawing methods, and the leading one, the hidden Markov model. Okay, here is the thresholding basic theory. Well, assume a histogram of the image responds to the function f(x,y). So, and then we make a value. As the image threshold. If the value of the fx is bigger or equal to t, we mark this point as 1, and if the value of the fxy is less than t, we mark it as 0. So the pixels marked as S1 responds to target, and the pixels marked as 0 responds to the background. And t is the value of the threshold. So t is a constant, and the method which set a threshold value to divide the image is called the thresholding algorithm. Well, the critical point of the theory is to find the best threshold value. But how to make the value optimal and to calculate out it automatically? Okay, then I will talk about the two classical methods and to do the compare them to see which one is better. So the first one is the iterative threshold algorithm. The steps is listed here. First one, I want to set an estimated threshold value t0 to do the image segmentation. And then to compute out use this value to compute out the new threshold. Then repeat to step 2 to step 4 until the difference of the t in the iterative process is less than the t0 that we assumed before. Okay, and then is the Ostu Threshold selection algorithm. The purpose of this algorithm is to find the optimal t that can make the variance, the sigma square, of the two regions become the max. The step seems is very complex here, but it can be easy to be approached in the MATLAB. Just use one MATLAB comment as the t equals to gray thresh. Okay, here is the code I designed for my MATLAB. Okay, I will briefly explain the code. Well, in order to test the two algorithms simultaneously and I want to integrate the two different results in just one figure. Okay, this is more obvious to inspect and compare each other. Okay, but sometimes the results cannot be distinguished from our eye directly. So it makes a comment to display the value of the threshold. You'll see it's T1 here and T2. Well, one thing I want to point out is when we use the Ostu method, the threshold value we get is a binary result. So we must to multiply by 255 to get the 8-unit results. Okay, here I want to show how my code works. Let's find the MATLAB I have open here. Oh, here. Oh, sorry. Here is the 3 pictures I want to show. The first one is here. This is a picture I took from the St. Augustine when I visited there. And the second one is a picture of the fossil image. The third one is a picture of the solar surface. Okay, let's test what will be happened. The code, The code I have already prepared. It's ready now, so makes the first one image. The name is A, so that's right. Oh, it's a long time. Okay, here's come out with the result. Let's see, this is the original image. We just to transform it to the gray level, and this is the histogram. The picture, the image in this corner is the iterative threshold algorithm, and this one is for the Ostu. As we can see, is very close to each other. So let's test which one is what is the threshold value. See, the T1 responsible response to the iterative one, and the T2 responds to the Ostu one. So let's see, the first one is 141.8392, and the T2 equals to 140. They are very close to each other, right? Okay, let's test another one. It's B. Image B. Okay, let's tap in the new name. Okay, that's right. Oh, see, it's come out. This is the original image, and this is the histogram. We can see from the histogram. The distribution of the gray level is perfect. So let's see what's the result. Ooh, still they are very close to each other. Let's see what is the threshold value. T1 is equal to 117. The first one is the 116. The difference of them is less than 2, so it's just regarded as the same. Okay, let's do the third one. The one is named as C. Oh, okay. See here. That's right. Okay, from the report here, we see is the picture is segmented perfectly, and this is the original image. I see the contrast of the value is bigger than the other 2 images. So you see the segmentation would be very, very perfectly. And we see from the final threshold value, see just selected automatically. You see it's 2 methods. It's just close to each other. Okay, let's back to my PowerPoint. Here I list a table for the comparison of the 2 values. You see is the figure 1, figure 2, figure 3, T1, T2, OC 100, 141, 141. Yeah, that's very close to each other. The same for the figure 2, figure 3. So what can we conclude? Okay, this is a conclusion I got. The threshold segmentation method is a great way to do the image segmentation task. Well, and the result of the iterative threshold algorithm is almost the same as the Ostu threshold selection algorithm, and I think the Ostu algorithm is preferable because the shorter code and easy to approach. However, the threshold segmentation method can only do the roughly segmentation, not the accurate one. So, to determine the determination of the threshold value is the endless problem to be solved. So based on this, more algorithms are developed to implement in different conditions to do the more accurate segmentation. Okay, this is the demonstration of my project. Thanks for watching. Bye bye.